Hello, this is video 4.3, Properties of Rational Functions of the form y equals a over x minus h plus k. Our objective for this video is that students will be able to determine the asymptotes, intercepts, and points of discontinuity, if any, of rational functions in this form, and we're going to be doing that by getting a common denominator. Make sure you copy the title and objective in your notes. What we have here are 8 rational functions. Look at them, know why they are rational functions, and then what I want you to do is pause the video and compare this column of rational functions to this column of rational functions and see if you can determine the difference between the two. Okay, we're back. This left column of rational functions are of the form y equals ax plus b all divided by cx plus d. Now this generic form you do not need to memorize. However, you need to be able to recognize that these rational functions contain only one quotient. And that's how they're different from this column. This second column of rational functions all have a constant that is either being added or subtracted from the quotient. Now in number 4, this quotient has the constant being added to it first, but the order doesn't matter, right? So all of these rational functions are of this form right here, right there, okay? And why is that important? Well, if functions are written in this form, we're going to have to look at them a little bit differently than the way we did rational functions of this form, which is what we have been working with up to this point. So, how can we find asymptotes, intercepts, and wholes of rational functions of this new form? Let's start by looking at an example. Let's find the asymptotes, intercepts, and wholes of f of x equals 1 plus the quotient 2 over x plus 3. Now, if I'm comparing this function to the form that I was given above, okay, this 1 here, hopefully you can see that that would be your k. That's your k. That's the k. This 2, what letter is that? It's our a. And the x minus 3 is essentially our x minus h. Now, you might notice that all of these the order is a little bit it is backwards from our general form, but from algebra we know that the order doesn't matter. So this function is the same thing as 2 over x minus 3 plus 1. What we're going to do is combine both of these terms. I'm going to look at this one, the original function. I'm going to combine both terms so that I only have one quotient, and I'm going to do that by getting a common denominator. Okay, so here's our original function again, and I want to get a like denominator so that I can combine the terms into one term, and hopefully you can see that our common denominator here that we want is x minus 3. So I just need to figure out what's going to go on the top. If you think back to algebra, to get a common denominator, figure out what your common denominator is. It's x minus 3. Okay, that's going to go in the denominator. We're going to write that in the denominator, and then you're going to multiply each term by the desired denominator. So I'm going to multiply 1 by the denominator of x minus 3 and 2 over x minus 3 by the denominator of 3. Well, when I multiply 1 times x minus 3. That gives me x minus 3 over the denominator of x minus 3. And we can, obviously that equals 1, right? This, when I multiply x minus 3 by this term, I get the x minus 3 is already there, so what happens is the x minus 3's actually cancel out, and it just leaves me with 2. Now that the denominators are the same, I can combine the numerators, giving me x minus 3 plus 2, and I know that since I am adding and subtracting here, really those parentheses do not need to be there, and I know that I can combine like terms in the top. X, the minus 3 and plus 2 make a negative 1, leaving me with x minus 1 over x minus 3. Okay, and now this equation is in the form of one quotient, and we know how to find the asymptotes, intercepts, and wholes of a rational function in this form. So let's take it from here. So, picking up from the slide before, here is my simplified form of the function. Now go ahead and pause the video, find your asymptotes, intercepts, wholes, and graph it to check your answers. Okay, we're back. Vertical asymptote, you should have gotten x equals 3 by setting the denominator equal to 0 and solving. Horizontal asymptote, the degree on the numerator and denominator equal, so it's the coefficients. The horizontal asymptote is the coefficients of x on the top and x on the bottom. It's y equals 1. Remember, for your asymptotes, they need to be written as the equation of a line. You will not get credit if you just put the number, because it is the vertical asymptote is the vertical line that goes through x equals 3. The horizontal asymptote is the horizontal line that goes through y equals 1. X-intercepts, set y equal to 0 and solve. We have one x-intercept at x equals 1. And y-intercept, if you set the x's equal to 0, so we're going to set that equal to 0, and that becomes 0, we're left with negative 1 over negative 3, which gives us a y-intercept of 1/3. There are no wholes on this rational function since there were no factors that canceled out with each other. There's the work for the x and y intercepts. And we're done. And we can graph this function, check it, make sure that our answer is correct. We see that we have we set a vertical asymptote through x equals 3. There's x equals 3, a little bit slanted, but you get the idea. The horizontal asymptote at y equals 1. There it is. X-intercept at x equals 1 right there, and a y-intercept at 1/3 right there. Okay? Now, why don't you try the next example? Copy the question down, and I want you to find the asymptotes, intercepts, and wholes, if any, of this function here. Go ahead and pause the video and start it up when you have found all the answers. Okay, here we go. The simplified form with a common denominator, you should have gotten negative 4x minus 14 over x plus 2, and you can read the rest of the answers. If you graphed the function to check your answers, you would find that vertical asymptote is indeed at x equals negative 2, and a horizontal asymptote at negative 4. Okay, and you can also check your intercepts. Bring your questions to class, and we'll see you tomorrow.